Electric arc furnace. Steel making on a smaller scale. This process is of major importance for scrap recycling, and so for the environment. The scrap consists of losses in the steel-making process and recycling products. The furnace will be filled with scrap and some anthracite. In the furnace, the meltdown takes place by means of 3 graphite electrodes located in the cover of the furnace. The price of this steel is competitive only if scrap prices are low, as it requires considerably more energy than the oxy-steel process. The electrodes are lowered into the furnace, and during the process, a sort of weld pool develops around them. In the cooler spots between the 3 electrodes, 3 jet burners give additional heat input, and so reduce the meltdown time. During the process, oxygen is added to maintain an oxidizing atmosphere. After some time, lime is also added. Boiling, due to carbon oxidation, helps to remove harmful gases like nitrogen and hydrogen. Chemical reactions between bath and slag bind undesirable elements like phosphorus and silicon. The oxidizing slag is continuously renewed by tapping the slag and adding new lime. Iron ore is added to improve the fluidity of the slag. The bath temperature is about 1650 degrees centigrade. Before tapping, again samples are taken. By adding aluminium during tapping, the steel is killed. After tapping, refining takes place in the ladle furnace. To maintain the correct temperature, here also heat input occurs via electrodes through the cover over the ladle. The amount of alloying materials is now determined by samples. Alloying materials, added to the bath to obtain the required quality. The reducing slag lowers the sulfur content in the bath. By argon injection, a homogeneous bath and removal of deoxidation products is obtained. The electric arc furnace process is used to produce structural steel as well as stainless steel. The process ends again with pouring the steel into ingot molds or with continuous casting. Here, the ladles, filled with liquid steel, are for reasons of efficiency transferred onto a turret. Again, argon is blown in to keep the bath stirred. The steel is cast into a tundish, which feeds a mold. This tundish serves as a buffer, allowing a continuous supply of liquid steel. By water cooling, the steel starts to solidify into a strand, which finally leaves the machine horizontally. Flame cutting separates the strand into slabs. Subsequently, the cooled down slabs are deburred, marked, and piled. Continuous casting was also developed because, by using killed steel, in the top of an ingot, a shrink hole occurs.